6.2 Law of Cosines. What we should learn. We should learn how to use Law of Cosines to solve non-right angle triangles, how to solve real life problems, and Heron's area formula. So another area triangle formula. So Law of Cosines is the other one we use when you don't have a pair, right? Law of sines when you have a pair, Law of Cosines when you don't have a pair. And here's the Law of Cosines. The one I'm most standard for is, this is probably the one we think about most. C squared equals a squared plus b squared minus 2ab cosine of c. And the general idea is whatever side you're looking for, you make that c. Right, because these are all just letters. They're all the same. But this is one that probably most people are used to. It's that, and then whatever side you're looking for, it makes c. You also have this formula if you're looking for the angle. It's just like manipulation of this moves up around. Same idea. Whatever angle you're looking for, just make that c. But that's Law of Cosines. So use it when you don't have a pair. So a lot of times people use Law of Cosines first. It's a little longer if they don't have a pair, and then once they use it once, you have a pair, you can use Law of Sines. So let's go here. Find the three angles shown in figure 6.2. So here's our thing. We want to find all three angles. So here's another rule. There's a tip. When using Law of Cosines, find biggest angle first when applicable. So I was just saying, if like something like here, right, you have all sides and you have to find an angle, you want to find the biggest angle first. So we want to find, in this case, we want to find angle B. The reason we do that is because it might be obtuse, and sine inverse does not get obtuse. Sine inverse only goes from negative 90 to 90. So it won't find the obtuse angles. Cosine could find the obtuse angles. So if anytime you're looking for an angle, make sure you find, if you're doing Law of Cosines first, make sure you find the biggest angle first. So we want to find angle B first. So we're using the formula. I would only give you this one to use. So I'm going to write that down. Cosine C equals a squared plus b squared minus c squared over 2ab. Most times I only give you one formula. This is probably the standard formula they give you. I got to find angle B. So don't overthink it. Just, that's the angle I'm looking for, right? So that goes here. That one also goes around here. So side B is 19. That goes here, 19 squared. And then the other two are A and B, doesn't matter. So one's 8, one's 14. 8 squared, 14 squared. 2 times 8 and 14. So let's rewrite that. Cosine of B is equal to 8 squared plus 14 squared minus 19 squared over 2, 8, and 14. I brought the calculator to show you how to do this one. Now, if you have an updated calculator, I would do alpha y equals. Let's bring up a fraction. So you can put it in without fear, right? 8 squared plus 14 squared minus 19 squared. Without that, you just have to make sure you put parentheses around. If you're going to do this without fraction bar, make sure you put parentheses around the top and the bottom so they know that they're all together. If you put a fraction bar, it makes it a lot easier. 2 times 8 times 14. So I get that. That's weird. I expected, normally they give you a decimal. Either way is fine, but just a little. So let's say you have cosine B equals negative 0.45089. And now I want to get rid of cosines. We'll do cosine inverse. So second cosine of my answer. I'll put second answer here. And we get 116.8. And good thing we did this first, because if we try to do law sines with this angle, it would not work. Angle's too big. Law sines only goes up to 90. It does not go past 90. Cosine does. So that's our first angle here. And the good thing about law of cosines is you never have two triangles. It's always a one triangle case. And the other good thing is you have to use it once. Once you have that, hey, we have a pair. Once you have a pair, you can do law of sines, which is usually a little easier. You can do law of cosines again if you want, but once you have a pair, most people just do law of sines. So we're going to find an angle, so we'll put the angles on top. So I'm going to do sine of 116.8 over 19. Let's find angle A. So I'm going to do sine of A over 8. And multiply both sides by 8. put all that into our calculator, figure out what it is real quick. Did it off camera, and I got this 0.3758. And then we'll inverse sine both sides. So second inverse, our answer. And we get 22, we'll say 22.1. So sine inverse, and we get 22.1 equals A. So now we have angle B, angle A. All we need is angle C. So remember, anytime we have a triangle, easy way to find the remaining angles is subtract from 180. So 116.8 minus 22.1. And that gets me 41.1. So that's all the angles of that triangle using law of cosines and law of sines. Okay, this next one, two sides and include angle. We're going to find all the remaining sides and angles. First thing I always check is see if you have pairs, and we have no pairs. Right? So no pairs means we can't do law of sines, we have to do law of cosines. And since we have an angle, that means we're looking for the side opposite of it. So we're going to use the law of cosines, that is c squared equals a squared plus b squared minus 2ab cosine c. And as always, if you're using this, I'm only going to give you this formula, so you're not going to have all three. So just need one. Whatever you have, whatever you're looking for is your c. So in this case, that's essentially my c. So I'm going to put a squared equals 9 squared plus 12 squared minus 2 times 9 times 12. And then cosine of the angle you have, 25. Right? Just whatever thing you're looking for, that goes for c. And then the rest doesn't matter. Just fill it in for a and b, doesn't matter. Because you're multiplying them all, it doesn't matter. This you just put it all into your calculator. So you put that, type that all into your calculator, and you get 29.2. So 29.2. I just have to square root it. So a equals square root that, second square root, answer, and I get 5.4. Let's round to 5.4 near 10th is fine. So again, once you do it once, now you could do law of cosines again if you want, but most people just do law of sines because now you have a pair. We have the a's. So we're gonna look for, let's do sine of b. Again, I'm gonna be a little apprehensive here. If you're doing law of sines, it's kind of a corollary to the rule up here, right? When you're using law of cosines, you want to find the biggest angle first. If you're doing law of sines, find the smallest angle first. Find smallest angle. Right? Because if this is obtuse, law of sines can't find it. So you have to do the smallest angle first. Let's do angle B, the smaller one. So we're going to do sine of 25 over 5.4 is equal to sine of B over 9. Again, I'm not going to do C because it might be obtuse, and if it's obtuse, law of sines can't do it. So then I'm going to solve for this. I'm going to times both sides by 9. I'm going to get sine of B equals 0.704. Sine inverse both sides. And I get B equals 44.8 degrees. So we have angle A, we have angle B. Now we need angle C. So remember, the easiest way to find the remaining triangle is you want to do 180 minus the other angles you have, 25 minus 44.8. I get C equals 110.2. So good thing I didn't do law of sines on that one, because if you did law of sines on this one, you would not get 110. Law of sines does not go past 90. So law of cosines, if you have a chance, always do the biggest angle first. Law of sines, if you have to use it, do the smallest angle first and leave the biggest angle to 180 minus. Okay, if I want to do an application real quick. So the pitcher's mound of a women's softball field is 43 feet away from home plate. So there's 43. And the distance between the bases is 60 feet all around. How far is the pitcher's mound from first base? So tell us this is 45-degree angle, perfect. This would be no pairs, law of cosines. So I just got to figure out what this guy is. So we're going to use the formula. C squared equals a squared plus b squared minus 4ab, cosine of c. Now remember, the general rule is whatever you're looking for is your c. So I'm looking for this guy, that's my c, which makes my angle 45. And the other two sides, which in this case are 43 and 60, are just a and b. It doesn't matter which one's which. 43 squared plus 60 squared minus 4 times 43 times 60 times cosine of 45. That's all equal to c squared. We're just going to type that all into our calculator and get an answer. Just caught a mistake. It's 2ab. I'm not sure why I said 4ab for. Plug that onto your calculator, you get 1800.329. Then we square root it. And c is approximately 42.43. So that's how many feet away the pitcher's mound is to first base in the softball field. Okay, so another application of law of sines. And this one involves bearing. Okay, so a ship traveling 6 degrees due east and adjusts course northward, showing traveling 80 miles in the new direction. The ship is 130 miles from its point of departure. Describe the bearing from point B to point C. So like how much did it turn here? So, well, first we gotta find this angle. So we're missing that one. So we're gonna use the formula I was giving you. So it'll be cosine of C is equal to a squared plus b squared minus c squared all over 2ab. Remember, the thing you're looking for is your c. So in this case, this guy is my c, and this guy is 139, and that one of these is 80, one of these is 60. Does not matter. Put that into your calculator. We get negative 0.9709 cosine c. We're going to inverse that. And c is roughly 166.15. So that's how long this line is here. It's 166.15. But now let's talk about bearing. So let me recreate this picture here. We're going like this and going like that. All right, we know all of this is 166.15. Remember, bearing is from north. So like if we make a little chart like that, there's my north. The bearing we want is this guy. This is bearing. So it's from the north to there is my bearing. So I know all this is 166.12. All we gotta do is subtract off the 90 from this corner right there. So I'm gonna do 90. We'll subtract off the 90. So 166.15 minus 90 gets me 76.2. So that's the bearing. If you want, you could say north 76.2 east. But really, since you're coming from the north, a bearing of 76.2 is all you need. 0.2. Okay, let's go to Haran's formula. So this is Haran's formula. It was founded by the Greek mathematician Haran. He found out, basically a corollary law of sines, that given any triangle with sides a, b, c, the area of the triangle is given by area is the square root of s times s minus a times s minus b. S minus c. You might be like, what is s? Well, s is just a plus b plus c divided by 2. It's kind of a crazy formula. Like, if you have all the sides of a triangle, you can figure out the area is pretty simply. That's Haran's formula. And we're eager to find the area of this triangle here. So Haran's formula is square root of s minus a, s minus b, s minus c, where s is a plus b plus c divided by 2. So pretty kind of crazy formula. So first let's find out what s is. So 53 plus 72 plus 43 divided by 2 gets me 84. And now that we have s, we can plug it all into our formula to get the area, which is going to be 84. 84 minus 72. I'm just going to go one by one. 84 minus 53. And 84 minus 43. And all we're going to do is type that into our calculator to get an answer. And we get 131.9 meters squared is the area. So that's Haran's formula. Pretty crazy formula. It's pretty straightforward. All you need is all the sides. That's why it's in the law of cosine side. But all you do is plug it in, find your s, and once you have your s, plug it into the equation, and you're done. So that's our third area of a triangle formula. So we have 3, right? We have a standard triangle, the standard formula, 1/2 base times height, but you need to know the height. Remember, height is like when you have a triangle, you need like a right angle. So it can be like this, as long as you have a right angle, that's your height. If you don't have a right angle anywhere, then you can use a oblique triangle, like 1/2 AB sine C, or you use, if you have all the sides, you use Haran's formula. But those are all different ways to find the area of a triangle. And that's the lesson.